This is a brief introduction to creating drivers in and route using the small basic compiler application. There's basically two different ways to create drivers for in route. One is using this basic application, which creates a .pst file. The other is to use C++ and to build it in Visual C++. So that's an option too. This one is handy because it uses a little standalone system, and so it makes it pretty portable, and it's therefore a little simpler and has become popular for that reason. So anyway, this PTDEB application, if you double click on that and open it, is this little PT Windows application, and it's very simple. If you go here and say I'm going to edit a script, it'll bring up a folder and this EBS file structure. Here's an example, this multicam. So if I open it up and bring it in here, you can get a sense of what's going on here. So here's the application. It's interesting, a lot of these you see were written a long time ago, but I can scroll down and see there's the ability to define global variables using structures. So these data structures are static and are standalone or defined separately, and so there's a document that defines what these data structures are, so you can use them in the driver. And then essentially it's a series of functions that do one of two things. They're either called internally to the application, or they are responding to the individual P codes that are going to be sent. And so things like start file will send a data structure, or end file, or job parms here sends a particular structure of data that can be utilized then in the driver. So that information, and it's essentially doubles, integers, and strings that then can be used within the driver to create output. And then you notice that each of these functions that responds to a P code returns a string, and so sometimes the string, a lot of times the string is empty, meaning that no output is necessary from that particular P code. It's just sending data then that can be used later. And then others will say a start contour will actually format output using the start contour data structure as the input into the formatting of this output. So lift Z, target X, target Y, those are all doubles in this case that are part of this start contour data that gets sent and then is formatted into a string. In this case, the return value of the function start contour is a string that then gets sent back to the PT. So remember, the PT is running this, and it's running the driver and making calls to the driver of these functions, and sometimes they're meaningful for the output and sometimes they're not. So that's where the driver makes those decisions, and so each of these functions, in this case the draw XYZ, is one of the sort of the more used calls, because that's where it's drawing the toolpaths that come in the P code file and the PCD file that are then formatted for output. Here in this case, the draw XYZ is going to draw this is an old driver. It's actually an HPGL driver, I see. Typically it would be a G-code driver, but that PD, that pin down, is an old HPGL command. And then it's saving values and saving kind of last XY and all that sort of thing. And so here's an internal variable that is going to be set or reset depending on where we're at in the file. So essentially it's a series of functions: draw arc, end contour, end job, set machine plane. So in this case, for example, set machine plane will send information. There'll be a PCD or a P code that gets sent, but it's not meaningful for the output file, and so it just returns an empty string. All of these return empty strings because they're not meaningful for this particular file. So once I've made a change to this driver, I can come up to run here and I can perform a syntax check. In this case, no errors are found. It'll tell you if there are errors found, and then when I'm done, I close it. If I've made a change, it'll ask me if I want to save the changes. So that's the editor, and then I can come in here and I can tell it I want to compile a script, and if I click on that and compile it, then it's going to come back and tell me that it compiled it and it's done, so it was successful. If it's not successful, it'll tell me that also, and so in this case that's the one I was looking at, and so it compiled this multicam_B, and it's a .pst file. So if I come in here and look at it, you can see that it's a .pst. Windows thinks that it's an Outlook data file with that extension, but a PST, which then goes into the end drivers folder in and route and would be used as an updated driver. So creating the drivers using this system is a matter of telling it I want to edit a script, and I can come in here and I'll choose another one here. And I can edit it. Here's one that apparently I edited back in 2007. And staying on top of comments and discussion of what the driver is accomplishing is an important aspect of it. Some people are better at that than others, but putting comments in about what's happening and why and all that sort of thing is something that we think is obviously real valuable. Here's one that's kind of talking about what happened with this particular edit, and then once I'm done with it, I can do a syntax check and then close it. Again, it'll prompt me if I want to save it, and then compile it. That's basically the sequence of events that you're going to do, and then of course move the driver over into end drivers, test it in and route, and there's another video that describes running the driver and looking at the PCD file and all of that sort of thing. So that process basically is how the drivers are edited and compiled and then tested in and route, and the sort of the process of creating drivers. The C++ version is a similar process. The functions that are called are very similar to the basic versions here. They just happen to be formatted for a C++ compiler, and they compile a DLL. And so in the CNF file, there's a parameter that is set that tells en route, or tells the PT what kind of driver, whether it's a PST or a DLL, is being used. And so then that chooses what type of driver. DLLs tend to be faster than these PST files. These are easier to create and more accessible to more people, and so both are good ways to do it. So anyway, that's an overview of compiling basic drivers for use with en route.